Good day, seniors. This video lesson we will study zeros of a polynomial. So meaning we will find all the values of x that will make a polynomial equal to 0. So before that, we need these two theorems to help us in finding the zeros. First, the rational zero theorem. According to this theorem, the set of possible zeros of a rational function of a polynomial function. So this is incomplete. The set of possible rational zeros of a polynomial function can be the ratio P over Q, where P is the constant and Q is the leading coefficient. The next, we will also need the Descartes rule of signs. This will tell us how many positive roots or how many negative roots a polynomial can have. So this will help us narrow down our choices in choosing among the possible rational roots to check whether the polynomial is 0 in that or not. So meaning to get the 0, these two will help us in doing it efficiently. So let's have this example. So given the polynomial x to the fourth minus 10x cubed plus 35x squared minus 50x plus 24, what are the zeros of this polynomial? First, the degree of this polynomial is 4. So meaning we are expecting 4 zeros. So we don't know how many of those 4 zeros are rational numbers or complex numbers. But according to the rational zero theorem, the possible rational roots, so I call it PRR, possible rational roots or possible rational zeros, can only be the factors of 24 over the factors of 1, the leading coefficient of x to the fourth. So break down, factors of 24 are plus and minus 24, and of course it's partner 1, plus and minus 12, and then plus and minus, of course it's partner 2, plus and minus 8, then plus and minus 3, and of course plus and minus 6, and plus and minus 4. So these numbers, there are 1, 2, 3, 4, 5, 6, 7, 8, 8 of them, 16 in total, including both positive and negative. From these 16 numbers, we can get the 4 rational roots we are looking for. Now, we will do synthetic division so that it's easier. Remember that we are looking for that number, that when we do synthetic division, we will have the last number in the third row or the remainder 0. So in that case, we found the root. So before that, let's use the Descartes rule of signs so that we can help narrow the choice between the positive and the negative numbers. So the number of sign changes in the polynomial, so according to the Descartes rule of sign, the number of positive 0 is either equal to the number of variations of signs, or simply the sign changes of p of x, or less than this number by a positive even integer. So we will simply check how many sign changes are in the polynomial. So positive and then negative, so that's 1, negative and then positive, so that's 2 sign changes already, then positive, then negative, then 3, then negative, then positive. So there are 4 sign changes. Now remember that there are four zeros that we're looking for, and according to the Descartes rule of signs, 4 of them are positive. So why we don't need to try the negative, so all the negative numbers here in our PRR, so erase that negative, so it's not among the choices already, because according to the Descartes rule of signs, it is very likely that all our roots are positive numbers. So here we are now choosing among only 8 numbers, and I'm looking for 4. So let's try my luck. I'll try 3. So 1 times 3, 3. Negative 7 times 3, that's negative 21. 14 times 3, that's 42. Then negative 8 times 3, that's negative 24. You see, I am very lucky. So the last number is 0, meaning 3 is a root. Now, after finding one root, I suggest that you write your polynomial into its depressed form, so it's x minus 3. That's one factor. And then the depressed equation that in the third row, of course, that will be x cubed minus 7x squared plus 14x minus 8. And then do the process over again. Just repeat that process. So this time you're now dealing with the smaller degree polynomial. This polynomial is degree 3. Again, you start by listing all possible rational roots, factors of the constant over factors of the leading coefficient. So it's 8, so it's simply plus and minus 8, plus and minus 4, plus and minus 2, and plus and minus 1. Notice that now we are now only choosing among 8 numbers in total, both of them 4 of them positive, 4 of them negative. Now, consulting the Descartes rule of signs, positive to negative, that's one sign change. Negative to positive, that's another. Positive to negative, that's also one sign change. So there are all 3 sign changes, and therefore there are 3 positive possible rational roots. So we must not pick among the negative, because if you do that, most likely you'll not get a 0. So here, okay, so now I'm only choosing 1, 7. Do your synthetic division again. Now I'm only choosing now among the 4 positive, and I think that let's try 2 here. So 1 times 2 times 2, negative 5 times 2, it's negative 10. 4 times 2, that's 8. 0. See, now we got another root. So this becomes x minus 3. Then this root x minus 2, and then the quadratic x squared minus 5x plus 4. And if you reach the part that the quadratic part, it's now easy because you can simply factor your quadratic, or if it is not factorable, you can simply use your quadratic formula. So anyway, so this is x minus 3 times x minus 2 times, this is factorable, so this is x minus 4, and then x minus 1. So your polynomial now is completely factored. It's now easy to see the zeros. So the zeros will be 1 from that factor, and then 2, and then 3, and then 4. So there are 4 zeros, all of them